Hello students, welcome back to We Learning. This is Lakshmi, your math tutor. I hope you're doing well. So, as you all know, We Learning is an online educational platform where we provide right to quality education for all the students. With that, We Learning offers SMS, that is Vista Smart School Management System. This is a tool which enables the management to handle complex tracking and teaching process. So I hope you all aware that we have started live classes from class 1 till class 10 in our YouTube channel. Our YouTube channel name is We Learning. So those who have subscribed our channel, thank you so much for your support. Keep supporting us like this. Those who have not yet subscribed our channel, it's okay. Right now subscribe our channel and support us. Also, do not forget to press the bell icon to get further notification. So today, what are we going to learn? In the previous class, yes, we have started, that is 3.4 exercise, and we have also completed it. Today, we will be continuing the same chapter, that is playing with numbers, chapter number 3, playing with numbers. Okay, so right from starting, we'll see what and all we have learnt. First, we learnt about factors and multiples. Next, we learnt about prime numbers, composite numbers, even numbers and odd numbers, where we also learned about twin prime numbers, right? So in the next class, what we have learned, we started to learn the divisibility rules. Divisibility rules of which numbers? Divisibility rules of 2, 3, 4, 5, 6, 8, 9, 10 and 11. So about these numbers we learned the divisibility rule. So next class we started to learn about common factors and common multiples. Okay, so here we also learned about one more thing. What is that? How to find co-primes of the numbers, right? So I hope till this you have understood very well, and also we have solved the exercise according to the topic wise. We have solved the exercise 3.1, 3.2, 3.3 and 3.4. Yes, so today we'll be solving next exercise, that is exercise number 3.5. So what we have to solve here? Yes, we will be continuing with the topic common factors and common multiples, but here we will be learning about prime factorization. Prime factorization, and here in this exercise we'll be solving and we'll be giving reasons for the given statements. So now we'll start with the exercise. So now we'll be starting with exercise number 3.5. So here, as I said, we'll be dealing the problems on prime factorization. Before that, it is a statements given here where we have to say whether the statements are true or false. So let us start with the first statement, that is, if a number is divisible by 3, it must be divisible by 9. Is this true? Is this possible? Just think about it once. If a number is divisible by 3, it must be divisible by 9. There is a condition, it must be divisible by 9. For example, if you take a number like 6, 6 will be divisible by 3 and 6 will not be divisible by 9. So this statement is not true. means it is false. It is false. So, the next statement is, if a number is divisible by 9, it must be divisible by 3. Here it says that if any number is divisible by 9, for example, if I take 9 itself or 18, next number 18. 18 is divisible by 9, it must be divisible by 3 also. Yes, it is true. If any number which is divisible by 9, that same number must be divisible by 3. Okay. So, the next statement, a number is divisible by 18 if it is divisible by both 3 and 60. So, 3 into 6 is 18. You can just say that, ma'am, 3 into 16 is 18. You can't just say that 3 into 6 is 18. 3 6 are 18. True. But let us take some examples. When they have given any form of sentence, try to solve it with examples so that you will understand whether the statement is true or false. So, here let me take an example, like if I take a number like 30, okay, 30 will be divisible by 6 as well as 3, but will that be divisible by 18? No, it is not possible. Let me take another number like 60. 60 will be divisible by both 3 and 6, but it will not be divisible by 18. So, this sentence is also false. It is not true. So, the next sentence, if a number is divisible by 9 and 10 both, then it must be divisible by 90. It is 9 into 10 is equal to 90. Correct? So, if any number is divisible by 9 and 10 both, then it must be divisible by 90. Yes, it will be divisible by 90. For example, if I take 180 as a number, when 180 is a number, it will be divisible by 9 as well as 10, right? 9 into 20 will be getting 180. Likewise, 10 into 18 will be getting 180. Correct? So, this will be divisible by 90. The number 180 will be divisible by 90. So, 180 is divisible by 90, and the statement, if a number is divisible by 9 and 10 both, then it must be divisible by 90. So, it is true. So, the next statement here is, if two numbers are co-prime, at least one of them must be prime. So, this condition, in the previous exercise, in the previous session, we have solved few problems on co-prime, whether those two numbers are co-prime or not. It means the common factor will be 1. At least one of them must be prime number. So, out of those two, one should be prime number, they are telling. Is that true? No. Why? Because when we will take any number just like 15 and 32. So, out of these two, they are not prime numbers, but when we take a factors and when we take a common factor, we will be getting just one as answer. So, these two are co-primes, right? So, by this we can say that the E statement, the fifth statement is not true. Okay. So, the next statement, all numbers which are divisible by 4 must also be divisible by 8. Again here it is like when a number is divisible by 4, for example 4 ones are 4, next 4 twos are 8, 8 will be divisible by 8, correct, 4 threes are 12, 12 will be divisible by 4, but will that be divisible by 8? Think about it. No, it is not divisible by 8. So, this statement also not true, it is false. If any number which is divisible by 4, it is not required to divisible by 8. So, the next statement, all numbers which are divisible by 8 must also be divisible by 4. Correct, no? So, you can just relate these two questions or these two statements with first and second statement, right? So, all the numbers which are divisible by 8, that will be divisible by 4. For example, 8 2s are 16, it is divisible by 4. 8 3s are 24, it is also divisible by 4. 8 4s are 32, it is divisible by 4. Yes, these are the statements which we have completed by telling whether it is true or false. So, 2 more statements are there. Think about it and solve it and state whether the statement is true or not. Try to give reason so that you will get the actual reason behind it, means behind the sentence. So, I hope you have understood this. If you have any doubts, just comment it so that we will teach again. So, now you will be thinking, what is this? A tree kind of structure? Yes, it is factor trees. So, we were discussing previously about prime factorization, right? Yes. So, in that we have this factor tree and also ladder method. So, ladder method we will discuss this later, but now what we have to do, the second question, here are 2 different trees for 60, okay? Write the missing numbers. So, this is the first tree and this is the second tree with the same number 60. So, first we will solve for the first tree. So, here 60, it is splitted as 6 into 10 is 60, correct? So, how much into 2 will be getting as 6? It's very easy. Just by looking at them, we can easily say that 6 will be getting 2 into, correct, 2 into 3 will be getting 6. Likewise, here also will be splitting. So, the bigger number will be splitted to the smaller numbers. This is how about we will be solving the factor trees. So, next is number 10. So, 10, we have to get the answer. 5 into how much will be getting 10? That's correct, 5 into 2. 5 2s are 10. So, now just verify it once. So, 60 will be splitted as 6 into 10. It is given in the question. 6 into 10 is 60, correct? So, 6 will be splitted as 2 into 3. 2 3s are 6. Likewise, here also 10 will be splitted as 5 into 2. 5 2s are 10. So, the next tree we will see here. It's quite different, not like this. Yes. So, here 60 will be splitted as how much? Don't know. 30, one number they have given, another number we have not. They are not given. So, here we have to find another number. How to find it? 30 into something will be getting 60. 30 into how much we get 60? 32s are. That's correct. 32s are 60. So, next. This 30 again it is splitted twice, but here just one number they have given. What is that? 10 they have given. 10 into how much is 30? 10 into how much is 30? It is 10 3s are 30. Okay. So, here the 10 is given, 10 they have split it, but both the numbers are empty. We don't know how much is the value. You can also take it as 10 into 1. 10 into 1 is 10 itself, correct? And the next number is 2 into 5. 2 5s are 10. And next number 5 into 2. After that we will get 10 1s are. So, here these 2 are repeating. So, here it will be 1, 10, 2 and 5. Whenever we are writing it, it shouldn't be one and the same number itself, correct? So, it should be any prime numbers because this is prime factorization in a factor tree method. So, the prime numbers here are 2 into 5 which will be getting 10, correct? 2 5s are 10. This is how we will be solving this factor trees. So, the next question here is, write the smallest 5-digit number and express in the form of its prime factors. So, smallest 5-digit number is, think about it. Yes, it is 10,000. Smallest 5-digit number is 10,000. So, now we have to express this 10,000 in prime factors in the factor tree method. Well, so we'll start with, this is smallest 5-digit number. Okay, so 10,000 will be splitted as 4 into 2,500. Correct? So here only again we'll be splitting it as 2 and 2. 2 2s are 4. 4 into 2,500 will be getting 10,000. Correct? So here this part it's done. So here is 2,500. Now we'll split it again. It will be 25 into 100. Correct? 25 into 100 will be getting 2,500. So this 25 can be written as 5 into 5. 5 5s are 25, right? So now again here this 100 will be written as 20 into 5. 25s are 100, correct? So this 20 again will split it as 5 4s are 20. We have to split it until we get prime numbers. So 4 again will be splitting it as 2 2s are 4, correct? So now if you observe at the end everywhere we got prime numbers, that is 2 2 5 5 5 2 2 5. At the end we have to take. We can't take this 4 or 20 or 25 or 100. Yes, we have to take only the last, the leftover, the last numbers is the prime numbers. Obviously, we'll be getting the prime numbers. So, this 10,000 can be written as 2 into 2 into 2 into 2 into, again come here, 5 into 5 into 5 into 5 into, again 5 into 2 into 2 into 5. 5 into 2 into 2 into 5. So this we'll write it in a order. 10,000 it will be. How many 2's? 1, 2, 3, 4. 2 into 2 into 2 into 2 into, how many 5's are there? 1, 2, 3, 4. 5 into 5 into 5 into 5. So this is the factors for 10,000 and all of them are prime numbers, right? So this is how we'll be solving the fifth problem. So the next question here is, they have given a statement and the statement here, the product of 3 consecutive numbers is always divisible by 6. Verify the statement with the help of some examples. We have to give some examples to verify the statement what they have given here. So the statement here is the product of 3 consecutive numbers is always divisible by 6. So the 3 consecutive numbers which am I choosing here is, let me start with the starting 2, 3 and 4. This will be 2 into 3 into 4. Why am I multiplying? Because they have asked about the product. 2 3s are 6, 6 4s are 24. And yes, 24 is divisible by 6. So the next number, next example which I will be taking is 5, 6 and 7. So that will be 5 into 6 into 7. 5 6 are 30, 30 into 7 will be 210. Yes, this will be divisible by 6, that is 210 will be divisible by 6. So you can just give 2 or more reasons, 2 or more examples as a reason for the given statement. Okay. So the next problem which I have chosen here is the 9th problem. In which of the following expressions prime factorization has been done? So we have to see in which of the following expressions prime factorization has been done or it has been not done. So, first one, it is 24, which is equal to 2 into 3 into 4. In prime factorization, at the end, we'll be lefting over with the prime numbers, that is 2, 3, 5, 7, etc. like that, right? So, here 2 is prime number, 3 is prime number, but 4 is not prime number, it is composite. So, we can easily say that by looking at 4, this expression is not prime factorization, like it is prime factorization for this expression, it has not been done. So, prime factorization has not been done. Reason? 4 is composite, that's the reason prime factorization has not been done in the first expression. So, the next expression we will see 56 is equal to 7 into 2 into 2 into 2. So, all the numbers are prime numbers. Here prime factorization has been done. You have to write it has been done or not, and if not done, we have to give the reason why it is not completed. So, the next question, that is the third expression, 70 is equal to 2 into 5 into 7. So, here 2, 5, 7 are prime numbers. So, here also prime factorization has been done. Okay. So, the last expression is 54 is equal to 2 into 3 into 9. So, here 9 it is composite, that is the reason this expression is not done with the prime factorization. So, prime factorization has not been done, and the reason here is 9, it is not prime number, it is composite, that is the reason prime factorization has not been done. So, we will move to the 10th problem. So, the last question of this session which we are going to solve is the 10th problem, and the 10th problem says that determine if 25110, that is 25,110 is divisible by 45 or not. So, hint also they have given, that is 5 and 9 are co-prime numbers, test the divisibility of the number by 5 and 9. So, here we will start 45 can be written as 5 9s are 45, right? Correct, no? So, 5 factors are 1, 5. Likewise, 9 factors are 1, 3, 9. So, here you can see that the common factor of 5 and 9 is just 1. By this, we can say that these two are co-prime numbers. Co-prime numbers. Okay. So, here the second sentence in hint, the second sentence is test the divisibility of the number by 5 and 9. So, first it is 25110. First we will start with the divisibility rule for 5. So, here divisibility rule for 5 says that if the last digit of a number is either 0 or 5, then it will be divisible by 5. So, here the last digit is 0. The last digit is 0, Therefore, 25110 is divisible by 5. By 5. Likewise, now we'll see for 9. 25110. This is for the 9 divisibility rule. So here we have to take the sum of all the numbers they have given. That will be 2 plus 5 plus 1 plus 1 plus 0. 2 plus 5, 7, 7 plus 1, 8, 8 plus 1, 9, 9 plus 0, 9. So it is 9. Therefore, 9 is divisible by 9. So, 25110 is divisible by 9. So, now we just cross checked that 25110, 25,110 is divisible by both 5 and 9. Here, can you relate it? It is divisible by both 5 and 9. Therefore, it is divisible, means the given number 25110 by both 5 and 9. Therefore, 45 is divisible to the given number, that is 25,110. That means 25,110 is divisible by 45. So, by this we will be completing the exercise 3.5. So, in the next session we will be completing the exercise, that is the next exercise 3.6 by revision of the topics which we have learned till now. Until then, stay connected with Vista's Learning. Do not forget to press the bell icon and also subscribe if you have not subscribed our channel yet. Those who have subscribed, thank you for your support. Keep supporting us, and also if you like our video, give thumbs up so that it means you have liked our video. If you have any comments or any feedback, comment it through the comments. Yes, you can reach us. With that, you can also reach us in we-learning.in, where you will be getting complete academics and exercise videos, not only of math, of all the subjects for all the grades. Until then, stay connected with Vista's Learning and have a nice day.